Welcome, everyone, to another broadcast of the Steiger Perspective. Disclosure has already happened. R. Wayne Steiger provides a unique commentary and point of view on the topics and subjects that affect our world today by showing how the future has been impacting our past reality. Now, here's your host, R. Wayne Steiger.
Thank you, Z-Man, and welcome, everyone, to another edition of the Steiger Perspective. Hope you're having a great holiday weekend here in the States and the rest of the world. I trust that everything is going good. Tonight, I have a special guest who is returning, Dr. Claudia Albers, who is a theoretical physicist, particle physicist, and we're going to be talking tonight about a number of things that is happening to our sun, our world, our skies, our solar system. So I would like to welcome you back, Dr. Albers. How are you?
Oh, thank you so much, Wayne. I'm very well, thank you, and I'm very happy to be here and once again discussing these topics that I research. And basically, it's about the stellar cores in the solar system and the effects on the sun and so on. Yes.
Yeah. Well, welcome. I have been living in the same place for nearly 15 years, and where my house is situated is that I have an east and west house. That's the door front is the east and the back is the west. And over nearly 15 years, Claudia, after you begin to see the tracking of the seasons, and it's quite interesting because where my house is, we can literally track the sun as it progresses north, for the summer solstice all the way to the winter solstice. And one of the things that I was actually talking to my wife prior to coming on live was the fact that we could always tell by June 21st, 22nd, that the sun would shine down our hallway. This was, of course, the summer solstice. We could see that. In fact, we had to decorate the house accordingly because the sun can really be very intense here where I live in Colorado. My point to this, Dr. Albers, is this. The sun is not in the same position that it was when we first moved here. It's no longer shining down our hallway. Now, that has some, broad implications, but as an observer here, I have seen this. Now, I have read the stories of the Inuit Indians, many other tribes around the world who have, in fact, said that the sun has changed positions. Well, I'm telling you tonight, and with everyone that is listening to us, that I can see it here. Now, so it's quite interesting when we see these kind of things happening.
Yes, and this is to be expected, and because our solar system, as I have been writing for a long time, has been invaded by another system, and I believe it's a much larger system, occupying a much larger region of the galaxy than our own solar system. It's a huge system with thousands of objects in it. It came in from outside our solar system, so it was in what is called the local interstellar medium outside our solar system. And we now know that this changed for quite a few years, and NASA actually hid most of the information about what was happening there. But there is some inkling that there was an increase in temperature, and dust came in from outside, and so on. So we have that, but we do know that the stellar cores are now here. We have images from coronagraphs from 1996 that shows that they were there then. And we have current images showing these very large objects in the sun's corona. So we have overwhelming evidence that they are here. And we also know what the effects are. The main effect is that they absorb energy. And now the analogy is this. When you have a hot object and a cold object, and they come into contact with each other, you have heat flowing from the hot one towards the cold one. The hot one has more energy and the cold one has less. Now, if you have energy flowing from the sun to another object, which is clearly what is happening, that means the stellar cores are depleted in energy and they're drawing energy from the sun. And this is one of the main things I discovered. But it's not just that. They don't obey normal gravitational law.
Well,
this is why we can have huge objects right next to the sun, and yet there's no huge collision. Because if you have an object with that sort of mass next to the sun, you'd expect such a collision that the whole solar system is destroyed, but that's not happening.
Well,
and that shows you that they are low in energy, they absorb energy, but this energy is associated with the gravitational force that they are able to exert on other objects. So when I discovered this, I came up with my own theory on how gravity works because I discovered this. But the thing is, as they absorb energy, they actually change the sun, because now the sun is getting low in energy because they're pulling its energy out of it. So what will happen is the sun's gravitational influence drops as well. And that would lead to eventually the planets moving away from the sun.
So would there's a whole lot that we just said in there. I'm going to try to see that.
Yeah,
so
I'm sorry.
It's fascinating. So for the listeners, I want to kind of step back because I think that I'd like to go into a little deeper. Now, you had talked about that you felt that our solar system, our quadrant of space, has actually been in interaction with a much larger system. Now, oddly enough, just yesterday, I read an article that the collision that astronomers are now beginning to give more recognition to is the current collision between the main part of the Milky Way and the Sagittarius ecliptical dwarf galaxy. So, as you were talking, you see, I think that this makes perfect sense because we're moving through space rather quickly, correct?
The
sun is, 550 miles per hour or something like that? And by the way, wouldn't we have more, Dr. Albers, of a helical, spherical movement through space as opposed to a flat plane?
Yeah, that is true, because what happens is the sun is moving and the planets are moving with the sun. So it depends on our perspective how we see the movement of the planets, but basically it is a helical path through space because of the movement of the sun. So we don't ever cross the same region of space ever.
Thank you. Because I think many people got this crazy idea that we somehow just stay in the same part of the neighborhood and we're never moving on.
Yeah. But the thing is, what we have to realize is what affects our planet the most is what is occurring in our solar system. NASA, on purpose, always turns our attention away from what's occurring inside the solar system to what's occurring out there very far away at the edge of our galaxy and in other galaxies or many light years away if they can. But the truth is what is happening in our solar system is so dramatic, but they don't want us to know what is occurring. And everything has changed because of this system invading our system. And I believe that this started happening actually quite some time ago in 1850. This is when the first part of this system reached the inner solar system. And it could have been small objects, it could have just been dust. But when it started interacting with the sun, it started causing the sun to produce more energy, to generate more energy. It's like the sun grew hotter and more active because of interacting with this matter, which actually pulls energy out of the sun. So you can imagine. Yes?
Go ahead.
So you can imagine.
Go ahead. Oh. It's likely I should get the. Go ahead. My apologies.
Okay, so if you can imagine that if you have a hot plate, okay, or a stove, a hot plate, if you pull more energy out of this hot plate, what do you expect it to happen? The plate gets hotter. So the effect of the stellar cores are actually to increase the sun's output, at least initially, when it has still a lot of energy. So what happened was the sun's magnetic field actually increased to 230% of what it was in 1901. So the fact that we have more cosmic rays in our solar system is not due to the sun's weak magnetic field, because that has increased over the years. What has increased the cosmic radiation is the sun itself, because the stellar cores cause the sun to react to their presence by becoming more active, by generating sunspots, by having solar flares, by having CMEs. The stellar cores themselves are producing these effects. And one of the greatest events that ever occurred was in 1859, the Carrington event, which I'm sure you have heard about, where the telegraph lines were active even though they were not connected, and the telegraph operators got terrible shocks from just touching the telegraph line points. And this happened in 1859. And as I said before, I believe they started coming in 1850, because that's when noctilucent clouds were observed for the first time on Earth. They were not observed before that time, because there have been many astronomers before that time, and they would write about everything they observed. And they never talked about noctilucent clouds, which are clouds in the upper atmosphere that emit light. And that requires an energy transfer to occur. And it's not through any normal mechanism that's available in our atmosphere that you would get these clouds. It takes the entrance of stellar core material, which then absorbs energy and absorbs electrons to cause clouds to then emit light. So this showed that the stellar cores, to me at least, had arrived in 1850. And then we got the Carrington event in 1859. And after that, we started getting very strong solar flares, but they only started occurring in 1989. We didn't get very strong X-class flares before then. And this again showed that the sun, through the interaction with the stellar cores, had weakened to the extent that they could provoke it into having these explosions, because it requires the sun to let go of its own matter for it to explode out into space like that.
Okay. Again, let's first let's explain to everyone what is a stellar core, because I don't think that has been explained when you talk about a stellar core. What are you describing?
All right. So stellar cores are stars or planets. At least they were stars or planets once, but now they have lost their energy. So they've become like dead stars. With low energy, they lose the ability to hold on to their plasma. So a star, as it ages, it turns into a red giant. And this can be explained by the fact that it loses hold on its outer layers, which then moves outwards, and the star expands into a red giant. And so these stellar cores have gone through this stage. They've lost most of their outer layers, which is gaseous, the outer plasma, and what is left is the actual core of the object. So it's solid. It's the solid core. There's very little material hanging around them. And I started calling them stellar cores when one of them was photographed in the close to the sun in the sun's corona last year in 2017. And we call it the blue stellar core because it was emitting blue light from the surface, which was obviously solid. And when I saw that it actually had little grooves, not little, they were probably very large grooves on the surface, but the fact that it had grooves told me that it was a solid surface. And then it had material on it that was crumbly and formed stripes on it. And it was losing this material. So this was one of the first observations where I thought, my goodness, these are actually objects with solid surfaces. That's when I started calling them stellar cores. And then my understanding of what they were actually developed from there, where I have realized that these were once stars. Some of them were planets, the smaller ones. And it turns out that there's not actually much difference between stars and planets. They both have these dense cores inside them, just like our planet does. Our planet has an inner core, and our planet generates energy in this core because there's radioactive decay occurring inside it, and that means it's fission. And this fission is releasing energy, which then powers the whole planet. And the same thing would happen with stars. Stars have the same type of core inside them. And so what is left of these objects is basically the core. They've lost most of their material that was hanging on around the core, like our sun still has. But even our sun, we can see that it's losing its corona. I'm sure you've seen the photographs of how the sun has larger and larger coronal holes, how it has permanent coronal holes at the North Pole and the South Pole. We can see our sun is losing its corona. These objects went through that process a long time ago. And now by coming to the sun, they're basically aging our sun. They're causing it to lose its outer material. They're causing it to lose its energy. They're causing it to lose its gravity. And so our sun is getting weaker, but at the same time it's more active because as long as it has energy within it, more energy is coming out of it. And I hope that explains what stellar cores are.
Yeah, I think so. And now, as you were describing that, again, just recently, they have postulated the theory, particularly with Neptune, that there was, and I'd read this morning, that there apparently was a very large object that moved very close to both Neptune and Uranus that caused Neptune to literally turn on its side, not once, not twice, but thrice.
Wow.
So this tells me that, a lot of people would say, well, why aren't we seeing more evidence, more in the astronomical community talking about this? And I keep reminding people what we know about our solar system is about enough to fill the tip of a needle. We still do not know. I don't think that really how our solar system really works. I mean, so stellar cores, to me, make perfect sense. I mean, I follow, as you and I know, we have our weekly show over on our YouTube channels, that we look at the instrumentations, and we can tell that there are anomalies within the data streams, correct? At least that's what, we consistently see happening more and more.
That's right. I mean, we see anomalies in just about all the data that we are now getting. But the thing is, you have to remember that there is the powers that be on this planet do not want the population on this planet to know about what's really going on in our solar system. As I said before, it started happening in 1850. I'm sure that the astronomers didn't understand what they were observing. They did observe the Carrington event. They saw how the sun suddenly developed all these sunspots. They saw the white flash, the astronomers of the time. They didn't understand that what was occurring with the sun had a cause. And the cause was the stellar core starting to invade the solar system and affecting the sun. I like to say that there is no effect without a cause. Now, the powers that be control NASA. And through NASA, they control what astronomers and physicists are talking about. Basically, the subject that I am talking about and studying is taboo amongst physicists and astronomers, because when you start talking and delving and researching the subject, you basically are not able to publish it. So that's the end of your publishing career. And soon after that, you find yourself without a job.
True. And excommunicated.
And if that doesn't work, you find yourself dead. And this has happened to several, including Dr. Robert Harrington and Dr. What is that other one? I forgot.
The guy that was killed in L.A.?
No, there's Schumacher. The one that saw what happened. Yes. Saw what happened with Jupiter when that comet came in, and he realized that what is happening is electrical interactions that are occurring in the solar system.
I want to back that up, because what we saw with Schumacher-Levy was remarkable. The fact that we could actually see a comet when it really begins to interact with a planet, particularly like Jupiter. Now, when Ison came through, what I found very interesting, and it's on the LASCO 3 images, I have the images of this, we were told that Ison basically burned up when it got into the corona of the sun. However, there are photographs now from LASCO 3 that shows, in fact, what it appears to be the same effect that we saw with Schumacher-Levy in now multiple bright spots of what looked like ice and broke up now and is now a string of smaller comets, and that this return flight comes back in does not bode well for us.
Oh, that's very interesting, because first of all, if we have a comet that goes to the sun and does not leave, to me that's a likely indication that that comet was actually stellar core matter, because this is what happens to stellar cores. They are attracted to the sun, because it's just like an insect being attracted to a bright light. Basically, the sun has energy. They don't have energy. They are attracted to the sun because of the fact that it has energy, and they can draw energy from the sun. And when they reach the sun, they don't actually leave anymore. They basically stay there, absorb energy from the sun. And I've been looking now at what's occurring with the matter that is coming into our planet. And what is actually happening is there is an interaction that occurs in our atmosphere where a cloud is formed around this matter. And I can now understand why a cloud is formed, because we have water in our atmosphere. And of course, as water molecules come in contact with this stellar core matter, which may be just some dust, then the water molecules would quickly lose energy, so they would condense on the dust itself very quickly and lead to the formation of clouds. But the clouds also emit light, and that has to do with the fact that this matter seems to absorb electrons and absorb energy, and that leads to the matter becoming ionized and then absorbing electrons. And when they absorb electrons, they emit photons. So there's light emission from the clouds. And this is why we have such colorful clouds in our skies. They emit pink light, and it's all over the place. And why is that? Because there's this stellar core dust and matter coming into our atmosphere all the time. NASA does not want us to know what's really causing these colorful patterns in our clouds. So they will use chemtrails. Yeah.
Yeah. I actually have photos from the ISS in the most gorgeous rose pink light. I want to get to a point that as you were talking, so we've been noticing in this current minimum cycle of the sun, and they're almost saying now it's becoming a Mulder minimum, and the next one is even forecast to be even lower. When we have seen in the last year and a half, that when their sunspots begin to come around, very active, we can see them on the limb as they come around and begin to face the Earth. The term has been used, the Earth-facing quiet effect. I am wondering, Claudia, if through some of the telemetry of the data now, because we see low solar wind speeds coming from our star, could it be that there would be a potential of a stellar core in now a semi-orbit between us and the sun?
Definitely. Basically, they are all over the place. They are in the sun's corona. There are some that are actually have been captured by our planet itself, and they are close to our planet. And we can see that this has happened because of these tidal events, where the ocean recedes, and basically it's an extreme low tide. And an extreme low tide can only be created when there is an object that is very close to the Earth. It has a weak gravitational pull, but by being very close, it causes a change in the level of the ocean. This is how the moon creates tides. So by understanding how the moon creates tides, and it does so because it's so close to the Earth, much closer than the sun, even though its gravitational attraction is nearly 200 times less than the sun. But because it's so close, it causes the ocean levels to vary and causes tides. So we would need an object that would come even closer than the moon to our planet to cause these ocean recession events. So we know we know they are there. They are interacting with our planet. It's not just dust. There are larger objects interacting with our planet, most likely energy bound to our planet, like the larger ones are bound to the sun, and causing these events. So we are being affected. I believe all the planets in the solar system will attract some of these objects to them. They will go everywhere. So when you talk about Neptune turning on its side, that's very likely. If you talk about our planet, yes, we're going to get crustal displacements due to these objects being here. And this means that our planet will turn in different directions. So this may be one of the reasons why we see the sun rising in a different place. And that is because our planet, its poles are not in the same direction they were before. They're not aimed.
Well, as an observer, you can see it. I mean, it's not something that you're going to rely someone else, and that. When you were talking about the tides, there are stories all over the planet, particularly those places that are within, I think it's 10 degrees north or south, maybe about 20, of the equator, where we're hearing these stories of bays, tidal bays emptying out. The most recent one, I think, is over in the Mediterranean now. Many are happening in South America. So we don't see this on mainstream news media because people would begin to panic. We don't hear the stories now of the shipping lanes, particularly down in where they call the roaring 40s, that these waves now, I heard one report of 200 feet. This is showing me, and then we got this strange thing called the North Atlantic anomaly, of which is impacting our equator. So the reason why I'm getting all to this, Claudia, is cosmic rays. This to me was the tipping point in my cognitive rational thinking. When the data is now coming in, this is what alarmed me. Between 2017, 2018, Claudia, I had the report looking at it right now, an increase of 30%. Now, this is what's alarming. Do you know that they're classifying airline employees? These are air crews, the pilots, the stewardesses, etc. They are now classified in the same classification as people working in nuclear facilities.
Well, Wayne, I'm not surprised. To tell you the truth, 30% to me is conservative. We may have even greater increases that possibly are not being reported. And the reason why I think this is occurring, and we have to go back again, don't forget the sun started being affected in the 1850s. It became more active then. So we've been living with a more active, much more active sun since the 1850s. And now it seems to be getting slightly weaker, and the solar wind is dying down. It actually stopped completely for one day in 1999. This is due to the stellar cores pulling energy out of the sun and making it hotter, basically, at least for a while it still had a lot of energy to come out of it. Now, the sun is declining, but that doesn't mean it's actually less active than it was before the system arrived. because there's actually evidence that it is not less active than it was, even though it's declined in activity and say it's maybe now less active than it was 30 years ago. But it's still more active than it was 200 years ago. You understand what I mean? Mm-hmm. And so what happens is the stellar cores, and especially as the sun gets weaker, find it easier to provoke the sun into having solar flare events. When you have solar flare events, you have acceleration of protons, and they reach relativistic speeds, and they become cosmic rays. So basically, the main cosmic ray source for our planet is our own sun. And the weaker it becomes, the more the stellar cores are able to provoke it into being a cosmic ray source.
Well,
and we know most of the cosmic rays cannot be coming from outside the solar system because the sun's magnetic field is now actually stronger than it was 200 years ago. So it's not about cosmic rays. We have to realize that the stellar cores themselves are causing the sun to emit these cosmic rays. But it's not just that, because the stellar cores are, as I said, in the interstellar medium, just outside our solar system. And they are interacting with that environment, and they are causing energy to be produced in that environment. Whatever matter is there that is not stellar core matter will cause more energy to come out of whatever's there. So there may be more cosmic rays coming from that interstellar medium itself.
Well, I don't know where it's coming from, but I do know that and what set off the alarm in the scientific community was the neutron monitor up in Thule, Greenland. Mm-hmm. And the report that I have right here in front of me is that they declared that the Earth has entered into a new epoch. They're calling it the epoch of cosmic rays. And we hit a level never recorded, and the thing about it is it continues going up. And I read as well, there's a company that is developing a application for the average air traveler. Now, they've been doing this with their employees, and here's what they found just a couple of months ago. A flight from Eugene, Oregon to San Francisco, 1 hour, Claudia, 1 hour, is now the equivalent of taking one chest x-ray. The further you go in the flight, the more of the radiation you're absorbing. So this is alarming.
Yeah. You see, it's not just the cosmic rays. Cosmic rays are fast-moving particles, relativistic particles. But the stellar cores, in the interaction of pulling energy and pulling matter out of the sun and out of the planets, cause radiation, high-energy radiation, not just particles to be emitted. And that would mean you would get gamma rays and X-rays, mm-hmm. and these would go to all-time highs everywhere. And they are being produced in our own atmosphere because the stellar core matter is coming in from space, interacting in our atmosphere, and causing this radiation to be given off. We do not detect X-rays and gamma rays and ultraviolet radiation. We only see the visible light. But the way we know that this radiation is being given off is through the strange colors that we are seeing in the sky. They are not just giving off visible light, though. They're giving off more energetic light than visible light as well. And one of the ways we know that is because there's now more ultraviolet radiation in the C range, which is the most energetic range, which is not even supposed to get to the surface of the Earth. There's more of it now reaching the surface of the Earth than it's supposed to reach the top of the atmosphere, and that would be produced by the sun.
I'm watching a real-time monitor of it. It's amazing. Yeah, this is the Nova FAR detector, if anyone wants to know out there. And this is 100 meters below ground. So, but the amount of neutrinos that I'm watching, even as we hit, and it's refreshing itself every, I think they're refreshing this at 500 microseconds.
Yeah.
So, it's...
And that's a neutrino monitor. Don't forget, neutrinos are very low interacting particles. Very few of them are being captured. But the other particles that are impacting our atmosphere in the cosmic ray range would be the protons. And as a proton impacts our atmosphere, the reaction causes a cascade of other particles to emerge. One of them would be the neutron, which is extremely damaging to living tissue. And it's not easy. Yeah, it's not easy to detect neutrons because they are neutral. They have no charge. But neutrons, when they enter tissue, because they are so heavy, cause a lot of damage. But other particles are being produced, and the pions, they do, and muons, the muons reach the surface and also damage living tissue. And of course, if you're in a plane at high altitude, a lot more of them will get to that altitude and cause a lot of damage to your tissue.
That is the alarm right there. I was one of those frequent flyers that, literally I was putting 200,000 miles a year. And and when I began to realize this, I've been studying this now since about 2014. It has only increased. In fact, I'm looking at a report from, this was June 10th, just last month, that in Norway, you folks that live up there in the northern latitudes of the northern hemisphere, you folks are getting pounded. But what was more shocking was a place like Oregon, and the amount of exposures of the increase of the radiation in general. So it's really quite alarming.
Yes, and why you will get more the closer you are to the poles is because of the Earth's magnetic field. Energetic charged particles spiral along the Earth's magnetic field, and the magnetic field goes in towards the poles. So as the particles come in along the magnetic field lines, they will reach a lower altitudes closer to the poles. This is why you should never fly on a flight that flies over the poles.
It's not
system with thousands, if not tens of thousands. I don't know how large it is. I just know that there are a lot around. I know that there are quite a few large ones, and there may be many, many small ones, planetary-sized ones. That nevertheless.
Go ahead. Yeah. I was just going to say, do you think that what we could do, maybe you could, is actually, it seems like we could almost classify these objects like in a destroyer class. These objects are destroyers of other planets, other stars.
Yes, absolutely. In fact, I have called it the destroyer system because this is what they would do. They will go into a star system and start absorbing all the energy out of the stars, whatever, if there's only one star, out of the star and out of the planets in that system, until they've absorbed all the energy, and all these objects in that system will become stellar cores themselves. In other words, they will become dead stars and planets. at which time they will join this system and they will move on with it to the next system because they are attracted to living systems that have energy in them. So this is like
living systems. I love that.
Yeah, it's a cancer moving through the galaxy, moving from system to system, destroying everything in its path.
A virus.
That is what's happening. It's like a virus, a sickness, yes. It's That's why I call it the destroyer system. It doesn't do it fast. Like I said, it started coming in 1850. That's 170 years ago, or nearly 170 years ago. It slowly absorbs energy. It causes everything to change in the meantime. This is why we're having so much upheaval on our planet. It's not just happening on our planet. It's happening to all the planets in the solar system.
Yes. So what happened right now on Mars is that Mars is now completely wrapped by a dust storm. We know that Jupiter is heating up. We know that Saturn is doing some strange things. I mean, you're right. And, as you were talking, isn't it interesting? Because human perception is that we have a very short memory. And as you pointed out, this has been going on for nearly now 2 centuries, maybe even longer than that, Claudia. But we are definitely beginning to feel the effects. Here in Colorado, up in Park County, 10,000 feet, Claudia, a tornado touched down.
Oh, my.
Now, a tornado, this is only the 6th time in recorded history that they have ever seen a tornado touch down at 10,000 feet.
Wow.
That's unheard of.
Yeah, but that goes along with what's happening with our planet because the stellar cores are drawing energy from the core of our planet just like they are doing with the sun. And that causes our planet's energy to increase at all levels. So the magma inside the Earth is heating up. Our ionosphere is getting more charged. And the weather systems in our atmosphere are powered by our ionosphere. Ionosphere is getting charged from space because of the stellar cores interacting in space around our planet, and it's getting charged from the core of our planet itself because of more energy coming up from the core. So that means that we are going to get more frequent and more severe thunderstorms and weather systems. There will also be a sharper change between high and low pressure systems. So as this energy increases, it means we're going to get more severity in weather. So the hotter weather will get hotter. The colder weather will get colder. Because there's just a sharp trend and a sharp change between low and high pressure.
Would this also aid in... Go ahead, I'm sorry, Claudia.
No, go ahead.
I was going to say, would this also aid in what many scientists are now expecting? This is not fringe, it's not out there. This is what mainstream science, if we can say that, has blessed it, that there is a pole shift coming. We definitely know with the magnetic poles, that's already well evident. A physical pole flip, I don't know, but I do believe that this could be aiding in a magnetic pole flip. Would you think as well?
The thing is, we are already having a pole shift. This is why you do not see the sun rising in the same place. In fact, we may be having an erratic move of the planet. In other words, it's wobbling backwards and forwards because of the action of these objects on it. And because they're moving in and out, they do not settle into a regular orbit because they do not obey normal gravitational laws. So
I have to have you back on to explain gravity to the audience because I don't understand gravity. I don't.
Okay.
But as you were saying, they would have, and their effects would as they would get close, it would impact us, and then it would move away, right?
That's right. This is exactly how they act. And this is what we see them doing in the sun. They come in very close to the sun. They make a plasma connection with it, pull matter from it, and then eventually they are ejected. They move away from the sun, and then they come back. So they are most likely in a regular orbit around the sun for most of the time. And then for some reason, they are attracted to the sun and come in for another refueling session, basically.
Sure. Yeah.
And so this is what happens all the time. They would do the same thing with Earth. And in fact, they've been observed in the same position in our skies by JFPs, taken pictures of it. And they stay in the same position for hours sometimes. And don't forget, only geosynchronous satellites are supposed to be able to stay in the same position with respect to the surface of the Earth. But they can do that because they make a connection with our planet so that they start rotating with it. They do the same with the sun.
I'm still trying to figure out how the moon sets up there. So, I mean, you know.
Well, the moon is actually in free fall, Wayne. The moon is falling towards the Earth. But because it has a certain horizontal velocity or tangential velocity, keeps missing.
Well, you know, as we get near to wrap this up, Claudia, I cannot help but not think is that if people would just look at the data, I mean, I was just, as we were talking, looking at another article on Venus, that Venus is, it's acting very oddly. We suspect it's probably a comet, but all of this is impacting us now in this time, and, you know, people are becoming more aware of this. You've actually published some books, so people can actually get those on Amazon, is that right?
Yes. All my books are on Amazon. I've just finished, I just published the 5th one, which is basically with my articles, thank you, that I have written. And you know, I came up with a theory on gravity. So my 4th one is basically explaining how that came about. And then the 5th book has the articles that I've written after that, using that theory and applying it. I'm still learning all the time.
We all are.
And understanding more and more about what's actually happening in our solar system. And
you know, it's brilliant minds like yours, Claudia, that helps all of us.
Thank you.
Because your inquisition, when you question, it allows us to be able to see what you have seen. And I know, you know, our YouTube channels, I can tell you, the audience that loves that. By the way, you do have a YouTube channel. I left it where people can link in, and that's where they can actually stay pretty current with you as well. They can subscribe, and when you post and have live shows, people can actually participate in that, correct?
Yeah, that's correct, because as I write articles, I make videos out of the articles so people can watch these videos and see what my current ideas on this research are. I do this continuously.
Well, I am a fan. I am a subscriber.
Thank you, Wayne.
Well, I'll tell you, Claudia, what I have learned from you over the years has freed my mind. I will put this, because we're about to wrap up here, but in the next 90 seconds that we have, I can tell you what we have found out about science, Claudia, is that we don't know science yet. We're still learning science.
Oh, yes,
and
definitely.
Yes, and that's why I love brilliant minds like yours that go out there. It reminds all of us that when you start saying that can't happen or that is impossible, what they are saying, Dr. Albers, in a nutshell, is that we know everything, we've learned everything, and there's nothing more to discover. And I don't believe that. Do you?
Definitely not. I think whatever we are getting to understand now is actually only the beginning. But the stellar cores have been a great opportunity to actually learn more about how the universe really works. I've learned a lot from observing them.
Well, you keep telling us, and I hope you come back on. Maybe get you back on here. It's been 5 months, so we ought to get it on long time. Well, I want to thank you for just coming on and sharing your brilliant knowledge. And y'all make sure to go over to her YouTube channel. And as I close out, make sure you support the Artists First Network. It's a place where freedom of thought still reigns, and it's still a good place to come and find some mind coitus. All right, folks, be good. We'll talk to you next week.